You're likely to be familiar with the rule of 10, which states that the cost for correcting a mistake multiplies by 10 with every additional engineering step. This obviously means that the earlier I'm able to detect and eliminate errors in my engineering process, the lower my costs for errors will be in the end. The TIA portal option SIMATIC S7-PLCSIM Advanced allows me to fully test the functions of my S7-1500 controller in a virtual way. This comprises not only a test of the controller's pure logic, I can also test communication, fail-safe modules, or web server functions. In other words, PLCSIM Advanced is the virtual controller for the SIMATIC S7-1500 controller family. I will subsequently show you the PLCSIM Advanced user interface and how to create a virtual controller in PLCSIM Advanced. Download a Step 7 program to this device and interact with the TIA portal. I double-click on the desktop icon to launch the PLCSIM Advanced user interface. You can now see that PLCSIM Advanced has been started in the background, thanks to the notification which appears below. If I right-click on the tray icon, I can open the PLCSIM Advanced user interface, the so-called control panel. I can use the control panel to create and manage virtual S7-1500 controllers, known as instances. Before getting started, I first need to choose the online access. I can choose between PLCSIM and PLCSIM Virtual Ethernet Adapter. If I select PLCSIM, communication is restricted to one PC. That is to say, all instances must be located on the same computer. This setting has the advantage that I can launch an instance quickly and easily. I merely need to enter an instance name and select the PLC type, i.e. Virtual S7-1500 controller or Virtual ET200SP controller. If I select PLCSIM Virtual Ethernet Adapter, then I also need to enter an IP address and a subnet mask for the instance name. I apply the IP address and subnet mask from the TIA portal project. To keep things simple, I select the PLC name, PLC_1. The IP address is 192.168.0.1, the default value from the TIA portal. The subnet mask is 255.255.255.0. If I click on Start, then the virtual controller will launch. You can see here that the hourglass is running. The virtual controller is booting. You can now see that the virtual controller has booted, as the yellow LED is lit here at the front, and the IP address is displayed to the right of it. Needless to say, I'd now like to download a Step 7 program to the virtual controller. To do so, I go to the TIA portal. On the TIA portal, I first need to ensure that the project can be simulated. Therefore, I have to make suitable settings in the project's properties. I right-click on the project to access Properties and select the Protection tab. The check mark here is essential, since it also allows you to simulate the project with PLCSIM Advanced. Since the check mark is enabled, I can continue. I can now download my Step 7 program to my virtual controller, as I would do for a conventional real controller. That I can do by selecting the controller on the TIA portal and proceed to Download to Device. Here I need to select the correct interface to download to the virtual controller. Here, we select the Siemens PLCSIM Virtual Ethernet Adapter and go to Start Search. The virtual controller has been found, and I can now download it. I now click on Load to finally download the program to the virtual controller. Next, I click on Finish and return to PLCSIM Advanced, where I finally launch the controller by selecting the virtual controller and pressing the Start button. The green LED is now flashing and the controller is configured with the loaded Step 7 program. We can now use the online functions on the TIA portal. To do so, we first go to Go Online on the TIA portal and see that we are connected with the virtual controller online. I have already opened a function block on the TIA portal, which we want to test later. This is a relatively simple block which we use to move a motor backwards and forwards. We now open the monitoring table briefly, which we use to check and test the function of the block. In the block itself, we now go to Monitor Everything, and we see that all values are set to false. If I now change the first value from 0 to 1, we see that the motor moves forward. If we change the second value to 1, we see that the motor moves backward. And if we activate the brake, we see that the motor stops. The block thus does exactly what it is supposed to do. Besides the Step 7 program logic test, I can also test other PLCSIM Advanced functions, such as the controller's web server. To do so, I first go to the Internet Explorer and enter the virtual controller's IP address. As you can see, the controller's web server opens. We can now see and verify all the web server pages, and even access self-created pages. You are now familiar with the key steps to using PLCSIM Advanced. I can now automate these steps, so that they run automatically to make my tests more efficient. PLCSIM Advanced provides an API for this purpose, an open data interface which I can use to manipulate data. We can now use a self-created application to write data into the controller or read data from the controller. We do this to carry out an automated module test. Siemens already provides a free application for this purpose, and we'll now take a look at it. The Siemens application comprises two small subprograms. I define my test cases in the first subprogram. To do so, I open a ready-made test object, which I then modify. As you can see, I can determine a test case for each control cycle here. There is already a test case for the brake function test, and one to test whether the motor moves forward correctly or not. I now create a new test case, which we want to use to test the move motor backward function. I confirm by pressing Enter, and can now define this test case more precisely. I use the Add Tags from Template button to import the function block interface from the TIA portal. This means that all input and output tags are listed automatically. I now determine the input values for my test case. This means that the command for the drive move is set to 1, and the direction is also set to 1 for this test. For this input parameter, I expect a return value of 1 for the motor backward, if the function block works correctly. Once I have entered the input values and the expected output values, I can save my test case, and I now open the second application. I launch my test case in this second application, i.e., I browse and select the corresponding XML file, which I have just created. I then use the Start Test button to start my test, and my test results are also displayed here. In our case, the test was successful. This means the program module behaves as I expected as a user. An XML file is also created automatically to document the test. It clearly documents the test with all input and output parameters and test results. To sum up, PLCSIM Advanced is a virtual S7-1500 controller, providing a comprehensive test of controller functions. PLCSIM Advanced can even be used as an automated system, thanks to the integrated API. There's more. PLCSIM Advanced can also be connected to plant or machine simulation models. This allows me to perform integral holistic tests of virtual machines and plants, But that's another story.